An abstract class is incomplete. You can spot an abstract class in a couple of ways. First, it has one or more abstract methods. The methods are incomplete because they don't have bodies, and the incomplete methods are declared as abstract. Also, the class itself is declared as abstract. Here's an abstract class. Here at the bottom you see the abstract method. Its name is getCount, and it has a return value of an int, but it has no body that can do that. And because it has no body, it has to be declared as abstract. You can have several methods like this in an abstract class, but only one is enough to require that the entire class be declared as abstract. Notice that the other methods now are complete. There's even a declaration of an int that is complete and can be accessed from the methods of this class and any subclass. This is fine, but it does not prevent this from being an abstract class. One abstract method forces the entire class to be abstract. Here is the abstract declaration for the class. Because of the abstract class, the compiler requires this declaration. You can actually declare a class to be abstract even if all of its methods are otherwise complete. Now, an abstract class cannot be instantiated into an object, ever. The only thing you can do with an abstract class is to use it as the superclass of another class. Here is a class that extends the abstract class I just showed you. Now, this would also be an abstract class because it extends an abstract class. And it inherits the abstract method, but it overrides the abstract method with a concrete method, so this class is not abstract. All of its methods are fully defined. Now, here in the main method, execution begins by the creation of a text window for display. Then, an object of this class is instantiated. A call to the inherited method startCount is made to set the counter to its beginning. This loop calls the getCount method defined locally to get the current counter value, and then calls next inherited to move the counter to the next value. The output looks like this. That's all an abstract class is good for, to act as a superclass. But this can be very useful for creating a clear design. For example, you could have an abstract class named Node in a subclass such as Number Node and Name Node and Marker Node and so on. You could store any combination of these objects in a collection of node objects and handle them as a group. Also, any method or data item you add to Node will automatically be added to all of them. But there is no meaning and no way that you could actually create a simple node object. That's a simple example, but I'm sure you can see how such an arrangement could be a good idea. You can imagine a class that has no data and all of its methods are abstract. That's a special case known as an interface, and that's the subject of the next lesson.